Hello, welcome to Austin's AP Calculus AB course. Today we will be going over questions 2 through 4, which is 2, 3, and 4. Okay, so first, for question 2, this is the position versus time curve for an automobile over a period of 10 seconds. Use the line segments shown in the figure to estimate the instantaneous velocity of the automobile at time t equals 4 seconds and again at time t equals 8 seconds. So remember, the velocity equals derivative with respect to time of the position function. And just in case you forgot what the derivative is the slope of the tangent line. So basically, let's look at this again. At t equals 4 seconds, let's encounter this first one. T equals 4 seconds is right here. So this is the tangent line here. So if we're looking for the instantaneous velocity of the automobile at time t equals 4 seconds, we are looking for the slope of this line right here, because this is the tangent line to this graph at t equals 4 seconds. And then we're going to do basically the same exact thing for t equals 8 seconds. Because we have this tangent line here, and the slope of this tangent line right here will be the instantaneous velocity for this automobile at 8 seconds. So, I mean, it's just using your same slope formula. So yeah, you like grab 2 points on the slope, and then, it's rise over run, and then boom, that's your answer. All right. And then for 3, this one says the accompanying figure shows the position versus time curve. So you want, for the first part, you're looking for the average velocity over the interval 0 to 3. So how you solve the average velocity problems is you want to put a point on the graph at 3 and a point on the graph at, time equals 0 and a point on the graph at time equals 3. Because if you look back here, that's what we're looking for, is in between 0 and 3. And then we're just going to draw a line connecting these 2 points. And then we're just going to take the slope of this line. And that will be the answer for part A, is it's the average velocity. This is different from the instantaneous velocity, which is from the tangent line. So if it says instantaneous means tangent line. Okay? Average means just put 2 fucking points on this on the thing and connect them and then take the slope of this line. Okay. Now for B, we have the values of t at which the instantaneous velocity is 0. Okay, so let's think about this from like a graph standpoint. If I have a graph like here, let's say I draw a tangent line over here. Okay, so the instantaneous velocity is, remember, it's going to be the slope of this tangent line right here. So obviously this slope is not 0, but the slope is 0 right here. When there's a horizontal slope is when this thing goes up and then just kind of stops and stalls right there. So once again, if it was like a graph like this, there would be a horizontal tangent line or a tangent line with the slope of 0 right here as well. So remember, we're looking for where the instantaneous velocity is 0. So it's where this tangent line's slope is going to be 0, which will be right here and right here at those 2 points. And then for C, we're looking for the values of t at which the instantaneous velocity is either a maximum or a minimum. So this again, we're looking, instantaneous velocity means tangent line slope. So I'm just going to kind of remove the shit that I put here earlier. But basically, we're looking now, if we're looking for where the instantaneous velocity is maximum or minimum, where the slope is the greatest. So we want to find the parts where this, basically, where this graph is at its steepest point. Is where we want to find it. So here's a really fucking steep point, and here's a really steep point. These are probably, if you just drew tangent lines here and then figured out the slopes of these 2 lines, those would be your 2 answers here. And then for D, we're looking for the instantaneous velocity when time equals 3 seconds. So we go back up to here, and yeah, time equals 3 seconds. So let's draw a tangent line right here. And we want to find the slope of this, because remember, instantaneous velocity means tangent line slope. So let's draw a longer tangent line, because look at this one kind of sucked. And then we could like put a point right there and like a point right there, or just put 2 points on this tangent line and then do the rise over the run, and then boom, you get your velocity at that point. So yeah, I mean, the important thing is really just instantaneous velocity equals slope of the tangent line. And then for 4, this is the basically the position versus time curves of 4 different particles on a straight line, and then we want to determine whether its instantaneous velocity is increasing or decreasing with time. So once again, remember, instantaneous velocity is the slope of the tangent line. So if I draw a tangent line here, that's a big slope. Here, it's a little bit smaller, and then here, it's getting pretty close to 0. So if the instantaneous velocity is the slope of these lines, then it's getting smaller, because right here, it's getting closer and closer to 0. And then you can kind of just use the same analysis. So you can try to, boom, this one is a pretty small slope, pretty close to 0. Here, it's getting bigger, and then here, it's very, very, very vertical, very high. So this velocity is increasing. Okay, that is kind of all I have. Please let me know if that helped. Good luck. Bye-bye.